So first we start with number 1, given that y is equal to ln of 3x squared plus 2x plus 4. So if we want to get the derivative, so this is number 1, what is the derivative of y equals ln of 3x squared plus 2x plus 4? Okay, so 1 over plus 4. Okay, so we write the derivative as dy over dx, that's the notation, 1 over 3x squared plus 2x plus 4, and then, is that it? Multiply to the derivative of 3x squared plus 2x plus 4, which is 6x plus 2. Okay, and then you can just simplify this by writing it as 6x plus 2 over 3x squared plus 2x plus 4. Okay, so please check your work. And then number 2, we have y is equal to log base 2 of 4x plus 5. This time the derivative is 1 over, so same rule, 1 over 4x plus 5 times 4x, and also there's one more down below is ln of the base 2. Okay, so this will be 4x. Now since ln2 is a constant, that's a number. If you get that in the calculator, you will get a number. You can write the ln2 before the 4x plus 5. Okay, so that should be the answer. 4x, it should be what? 4 lang, 4. Okay, so 4, no x, so 4. Anything else? Correction? Did you get the same answer? Okay, so that's how we get the derivative of logarithmic functions. It could be an ln, it could be a log. We use ln of the base whenever the given is log, but for ln, why did we ignore the ln of the base for the ln of 3x squared plus 2x plus 4? As you can see in our 2 examples, in the second one we wrote ln2. How come in the first one we went straight to 6x plus 2? Because the ln e is equal to 1. Tama? Okay, the base of the logarithm is e, so ln of e is equal to 1. So no need to write. Okay, it's always equal to 1.